All right, our final strategy for systems of linear equations is called elimination. For this strategy, we're using this idea of elimination, meaning that we're going to completely get rid of one of the variables from our system so that we can solve and figure out what one variable is, and then we'll go back and substitute it back into one of the equations to figure out what the second variable is. Alright, so using elimination, we're going to go back to elementary school and we're just going to start to add, kind of like we did when we would just add the different columns. We would add the ones column, the tens column, and the hundreds column, except now we're adding like terms. So as we start here, we're going to have negative 4x's and we're going to add 6x's. That's going to leave us with 2x's. And now as we add the y's, this is why it's called elimination, is because we have a positive 2y's and a negative 2y's. Those are going to completely cancel out and eliminate each other, so we have no y's left. This is going to be equal to the other side of our equation then has negative 2 plus 6. Well, that's going to be 4. So now to solve for x, I could divide by 2 on both sides, and I would end up with x is going to be equal to a positive 2. Once we get here, now we're going to go back to our idea of substitution. Because we know that x is equal to 2, we can plug that into either equation here. So I'm just going to use the bottom one and we'll run through it pretty quick. So we have 6 times 2, and then we have minus 2y is equal to 6. 6 times 2 over here is going to be 12. That means we have 12 minus 2y is equal to 6. So then we would subtract 12 to the other side. That's going to leave us with a negative 2y equals a negative 6, and then we would divide by negative 2 and we would end up with y is equal to 3. So again, we always want to write our answer in a coordinate, so we're going to write our 2 first, so 2 comma 3, and make sure you put parentheses around it there to show our final answer would be the point 2, 3, and that's where those two lines would intersect. Alright, let's try a second example here. Again, when we use the strategy of elimination, we're always going to add them together. But we run into a problem here, because if we would add these together right now, we would have 3x's, and 3 more x's would be 6x's. Here we would only cancel out a few of the y's. We would be left with a negative y, and nothing's going to cancel out. So before we can effectively use the strategy of elimination, we are actually going to have to figure out what variable can I get to cancel out. Well, 3x's and 3x's look kind of close to the same thing, but the thing is we need one to be an opposite of each other so that they cancel out. So if we were to use this idea of the distributive property and multiply everything by negative 1 right now, we would get a negative 3x and then plus a negative 5y, and that would equal a negative 23. When we would use this idea now if we go to add them together, we would actually be eliminating the x's because we would have 3 negative x's and 3 positive x's. Okay, so we multiplied everything by a negative 1. That just made it possible to eliminate one variable, but if we multiplied one thing by the negative 1, we had to do it all the way through that equation so that the values of x and y stayed the same. So now using elimination, we know that the x's will cancel out. We now have a negative 5y and a negative 6y, so that's going to be negative 11y. And now we have a negative 23 plus a negative 21. That's going to equal negative 44. From there we can solve for y, and we're going to end up getting that y is going to be equal to 4. And now we can take y equals 4 and substitute it into either equation. I'm just going to put it into the bottom equation again. So we have 3x minus 6 times 4 is going to be equal to negative 21. 6 times 4, that would be a negative 24, and we would end up adding it to the other side. So we would end up with 3x equals negative 21 plus 24 would be 3. And so then when we go through this here, 3 times 1 would be 3, so x is going to equal 1. So again, we want to write it as a coordinate point. So our final answer would be 1, 4. Make sure that you have the x in the x spot and the y in the y spot. So we would end up with 1, 4 as our point here. Alright, so again, we're going to be using this idea of elimination, which means we're going to be adding our equations together and adding the like terms. Okay, but we run into a problem again with this one because nothing's going to cancel out immediately. Even if we multiply something through by a negative, nothing's still going to cancel out. So now we need to ask ourselves, is there a common multiple that I can use that I can help make something cancel out? So here we know that 2 times 2 is going to be 4, and so that would get us close. And because this is already negative, if we multiply just by a positive 2, we're going to end up with a negative 4 that's going to cancel it out. So if we multiply by a 2 here, we're going to have to multiply by a 2 on all 3 parts of our equation. So that's actually going to make a new equation that's going to look like negative 4y plus 6x is going to be equal to 18. Okay, we didn't have to use that negative because we just need our y's to cancel out. It's okay that the x's don't cancel out because we can solve for that. So now when we go to add these together here, our y's are going to cancel out because we had negative 4y's here and a positive 4y's there. So our y's have been eliminated. Okay, then we're going to add our 6x and our 4x to get 10x's. And that's equal to, over here, we have now 18 plus 12. Again, we use this middle equation to rewrite the top one, so we can just forget about that one for now. So 18 plus 12 is going to be 30. And when we solve for x now, x is going to equal 3. Okay. Once again, we have to have a value of y, though, before we're done. So I'm just going to use that bottom equation and plug in this value of x. So we're going to have 4y plus 4 times 3 is equal to 12. And 4 times 3 over here is equal to 12. I'm going to subtract that to the other side. I'm going to end up with 4y equals 0, which means that y would have to equal 0. And like always, we're going to write our final answer in the form of coordinate point. So we write our 3 for the x value first, and then 0. So our final answer would be 3, 0, meaning that x is going to equal 3, and y is going to equal 0. And that would be our final answer there. So hopefully this video was helpful in helping you figure out how to use the strategy of elimination. As a reminder, we're always going to try to add the 2 equations together. If nothing's going to cancel out automatically like it did in our very first example, you might have to multiply something through by a negative, like our second example had, or like this final example here, you might have to find a common multiple to help you be able to actually eliminate one variable, and then you can solve for the other one. Like always, if you have questions, you can always comment down below, and I'll do my best to get back to you.